Now, the question is, when you are doing regression analysis, why do you need to have information about the correlation? What is the significance of correlation in regression analysis? That's what I mean when I say, what is the relationship? But when I'm asking you to explain the relationship, that's what I'm talking about. Of what relevance? Of what relevance is correlation to regression analysis? Yeah, the explanation you gave is very correct. That's the difference. Okay. Regression talks about creating a model which defines the relationship between two variables. Okay. Correlation, on the other hand, measures what? The relationship in terms of strength, right?
Yes.
Yeah. So why is it that when we are doing regression analysis, or are you aware? Hope you are aware that when we are doing regression analysis, we always deal with correlation. I hope you know that.
Yes, sir. Yes, sir.
Okay. Why is that? Why?
Because I think because if we have a positive correlation, it will affect the regression, and also the negative correlation also affects the regression as well.
Okay. Okay. Thanks for the attempt. The negative or the positive correlation affects the regression. Does it affect the equation?
Hello, sir.
Does it affect the equation, the model? Yes, please.
But but what we are looking at for this p-value, can we say it's also correlation?
The p-value.
What we are doing.
It depends. It depends on the type of problem you are solving. Okay. For example, when you do correlation,
Okay.
You can also have p-value. Okay. So it depends on the type of problem. Talking about p-value, that's a general thing. When you are doing hypothesis testing, generally, that's when you talk about p-value. That's when you talk of p-value. Is it clear, please?
Yes, sir.
Okay, so what I'm saying is this. There's something I want us to see here. Okay, I just did a scatter plot. I believe this is not new to any one of us. Okay, so now let's put a trend line. Linear trend line is okay. And then let's display equation. Let's display R squared. What is R squared really? What's R? This arrow you are seeing here is actually correlation. Okay, this arrow is correlation. And we all know that R square value is very important in correlation. Okay. So, and this arrow, it helps you to determine whether this model has integrity or not, whether it's usable or not. The model has been created quite all right, but arrow square will make you take a decision whether to use the model or not, isn't it?
Yes, sir.
Okay. Now, what is arrow squared? Arrow squared is correlation squared. So let's see it so that you see what I'm talking about. How do we compute correlation? What function? Somebody remember that? we use the Correl function, right? The Correl function. Now let's compute the correlation between these two. It's asking for the first array. Select that, comma, the second array, x, y. You see the correlation value is giving us, right? Now, this correlation value, I just told you that correlation is actually arrow, which is actually Spearman's coefficient of, Pearson coefficient of correlation. Okay, not Spearman now, Pearson's correlation. Okay, so that's arrow. This value you are seeing here is arrow. Let's see. Let me format it properly. Sorry. This value you are seeing here is simply arrow. This value. Is arrow. This correlation is arrow. You can use a Correl function or you use what we call the Pearson function. You get exactly the same because it's actually Pearson coefficient of correlation. Or use the Pearson function. You use the Pearson function, you get just the same thing. You see the same value you are getting. Okay? So it makes no difference whether you use the Pearson function or use the Correl function to compute your correlation. So now, see the interesting thing here that I want you to see. Now, let's do something here. So now let's type arrow squared. This square, that's arrow squared now. We did this the last time. I told you superscripts used to do that. Okay, now. So if arrow is this, tell me what formula do we use to get the square of this? Can you help me with that? What's the formula? There are different ways you can do that. There are different ways. You can use a power function, comma 2. That's arrow to the power of 2. Can you see the value is giving you? Compare this with this arrow square. They're not the same thing.
The same, sir.
So you see that this arrow square we've been talking about is simply the square of correlation. Okay. Which means even when you do your regression analysis, is the correlation between the two, correlation between the two has something to do with whether or not you are going to accept the use of this model or not. Okay. Regression defines the relationship between the variables, but correlation is what determines the strength of the relationship. Determines the strength of the relationship. How strong is this relationship? Okay. So that is the way it is. Hope this is clearly understood.
So, sir,
Okay, yes.
since the correlation determines whether you use the um, regression model or not,
Yes.
so what value will the correlation give you that will determine the usage of the regression model, and what value will it give you that you have to discard it, you don't have to use it? Is there any value for that?
That's a good question. Can anybody answer that question? Anyone want to attend that? Okay. Well, that's a very good question, like I said. If you have R squared of 70% or more, okay, you accept the model. That's a good R squared value. If you have R squared of less than 30%, which is like 0.3 something or downwards, that is a low or poor R squared value. In such a case, you discard the model. Even though it has created a model for you, but you cannot confidently use it. You're not sure it will produce the desired results. Okay. But if your R square is between 3 and 7 within that range, then you can decide to review the model, review it, maybe make some adjustments, and then test again and all that. Decide whether or not to use it. Okay? But to answer the question, it is when it is 70% or above, like 0.7 above, is considered a good, a strong relationship. Is the explanation clear?
Yes, sir, it's very clear. I think you mentioned it earlier before
Yes.
in the previous class.
Yes.
I just forgot.
Yes. I did. I just
Yeah,
had to say it again for a reminder.
yes, sir. I also remember now.
Okay. All right. So to remove this pink stuff, how do I remove it? Can somebody tell us? We are data analysts now, so I'd like to be hearing from you a lot now. How do I remove this formatting?
So I think you click after highlighting it,
Yes.
click down. There is a small box by your right.
Here?
This box, this one.
Which box?
It's
This
by
one.
the edge.
Okay, this one.
Yeah.
Okay. Yes.
Then go to play.
Okay. Yes.
Click on it. It didn't work. Okay.
Well, that was a very good attempt anyway. That was a good one. Okay, the same thing is here. But when you drop it down, you can clear just the format. Okay. Okay, so these are the things you have to deal with when you are cleaning data. Okay, these are some of the things you have to deal with. First of all, let me start with the irrelevant fields, irrelevant information, information that are not important when it comes to analysis. The information that you are not needed. For example, let's say you want to analyze, do analysis with this data. You have to know what exactly, what's the purpose of analysis? Analysis is to get insights, okay? To get some information that could help in decision making. Now, if you want to analyze this data, you have to know exactly what kind of information is needed. If, for example, your analysis, you want to carry out an analysis on the grades. Maybe what you are interested in is to know something about the grade distribution. Maybe you want to know what percentage of people get A's, what percentage of people get B's, and all that. In that case, and if it's not a campus by campus thing, okay, if it's grade that you need, you want to work on, then of course, you don't need, in this particular analysis, you don't need registration number for anything. In fact, for most analysis you do, you don't need something like registration number at all. So you remove it, okay? That's part of data cleaning. So those things you don't need, you knock them off. Don't forget the data you are using is a duplicate copy, not the original copy that is in the records of the organization. They just give you a copy, so you can play around with that copy. You can delete what you want to delete and use what you want to use for your analysis. So the information that are not relevant for that analysis, you knock them off so they don't just occupy space and cause confusion. That's what I mean by removing irrelevant fields. So as you are doing that, you are actually cleaning the data. Cleaning the data means you are trying to eradicate anything that it will either hinder your analysis or anything that is not needed, that is not relevant, it's not needed in the analysis, that will not contribute anything to the analysis. You remove them. Or something that will lead to your getting unexpected results. You remove them. That's cleaning. Okay. So like I said, registration number is almost never needed. Okay. Now, if what you are interested in grades, you are not interested in score, you could knock off the scores as well. Right? So that's that. Then inappropriate format. The data may be in a format that you don't want. Let's say, for example, you are dealing with figures, with numbers, and the numbers are in various formats. Some are in 2 decimal places, some are in 1 decimal place, some are, something like that. Okay. Okay. So let's say this one now is something like this. Imagine the data like this, for example. Okay. It may not be what you want. So you may want it to be in a format that makes sense. Okay. So whatever, if it's financial figures, for example, you could make it like this if you like. Okay. Whatever is needed, you that is doing the analysis, you should have information as to what is, what you need in the outputs. Okay. So when you are removing all those inappropriate formatting, you are cleaning up your data, or some items are bold, some are underlined, and all. You don't need all those things for when you are doing analysis. If some items are underlined, some are bold, some are in italics. Yeah, some are in italics, some are bold, some are red, some are blue. You don't need all those things, or just like this one is now. You don't need all those things for when you are doing analysis. Okay, just clean up everything. The data should look clean and neat, right? Now, that's the original data, but your final output, you can format the final output in a way that is appealing and presentable. Okay, so inappropriate formats are corrected to what is needed. That's cleaning. Then sometimes you talk about missing values. Of course, inaccuracies. Cleaning of data, you have to check. When you are cleaning data, you look at the data and be sure that as much as possible, you check to see that the data is correct. Okay? To see that the data is correct. For example, you are looking at salaries. Let's say you are dealing with salary data, and one person, everybody's salary is following a particular order. Then one person's own just shoots up and is very big, very large figure, and there's nothing that indicates that the person is a very senior worker. Then you have to check. Maybe there's a mistake there. Are we together?
Yes, sir.
Okay, so maybe there's a mistake. So you have to check. Okay, that's part of cleaning. So making effort to see to it that the data you are working with is accurate. Okay, and wherever it is possible, you have to liaise with those that gave you the data to ensure that whatever you suspect to be inaccurate is corrected. Because if you work with inaccurate data, you are going to get inaccurate results, garbage in, garbage out. Okay. Then invalid data. Let's say like we are talking about scores now. This is supposed to be over 100. And you now see somebody got 900 and something. One person now got, it may not even be that high. Somebody now got 120%. Okay. So that data may not be valid. Okay. Or 500. When other people are getting 71, 75, 40 something, 50 something, then one person suddenly gets 540. That's invalid data because it's over 100. You expect scores to be between